Hello everyone. In this video, we cover varying insurances. Consider an n-year term increasing insurance issued to a person at age X. Death benefit is BK equals K plus 1, payable at the end of the year of death if death occurs between ages X plus K and X plus K plus 1. That is, if the individual dies before reaching age X plus 1, the death benefit is 1, payable at this time point. And if the individual dies within 1 year before reaching age X plus 2, the death benefit is 2. By the end of the n-year period, the individual dies within a year before reaching age X plus n. The death benefit is n dollars, payable at this time point. Let Z be the present value random variable for this insurance. And here we have the full PMF table. With this, we can get the expected value of this insurance. The actuarial notation for n-year term increasing insurance is given by this. IA denote increasing insurance. By definition, the expected value, the summation of a product of 3 terms. K plus 1 is the death benefit amount. And then nu to the power K plus 1, this is the present value factor. And then multiply by the last term, this is the probability of death within this year. And then we can also get the notation of the expected value of Z squared. However, for the second moment of increasing insurance, we don't simply add the pre-superscript 2 attached to the actuarial notation IA. Recall the pre-superscript 2, this corresponds to the expression. We simply replace delta by 2 delta. That is, nu to the power K plus 1, we replace with nu to the power 2 times K plus 1. However, for the definition of expected value of Z squared with the increasing insurance, we not only change the delta to 2 delta, the death benefit amount here, we also need to square it. So this is not a simple change from delta to 2 delta, from expected value of Z to the expected value of Z squared. And therefore, there's no standard actuarial notation for the second moment for increasing insurance. And then we have the usual definition for the variance of Z. Other variation. Increasing whole life insurance. Same death benefit pattern, except that the death benefit will increase by 1, and the death benefit is payable at the end of the year of death whenever the individual dies. And the notation for increasing whole life insurance is IA with subscript X. The next variation, the n-year increasing endowment insurance. Death benefit K plus 1 payable at the end of the year of death. Same pattern. However, if the individual survives by the end of the n-year period, the insurer pays n at time n. Same pattern, same amount of benefit. However, for the last payment, the payment of n, as long as the individual survives beyond age X plus n minus 1, the insurer definitely will pay this amount n. That is, the probability of paying this value is n minus 1 px. The notation for increasing endowment insurance is IA, and then the subscript X colon angle n. Next, we go through the decreasing insurance. For an n-year term decreasing insurance, the death benefit is n minus k, payable at the end of the year of death if death occurs between ages X plus K and X plus K plus 1. That is, the death benefit, if the individual dies within the first year, the death benefit starts at n. And if the individual dies in the second year, the death benefit is reduced by 1, which is n minus 1, until by the end of the N-year period, the death benefit is reduced to what? Let Z be the present value random variable. This is the PMF table. And then we can get the expected value. The actuarial notation for decreasing insurance is DA. And then we have the expression. For the second moment, and again, there's no standard actuarial notation for decreasing insurance. And these are the expression for decreasing insurance. All right, let's consider a 4-year term increasing insurance. The benefit pattern, if the individual dies within the first year, the payment is 1. The death benefit amount is 1. And then in the second year, the death benefit is 2. This is the death benefit pattern. And then for the 4-year term decreasing insurance, the death benefit start with 4 in the first year, and then decreased by 1 subsequently. Let's combine these two together. The bottom part, we have the increasing insurance. And then the top part, we have the decreasing insurance. And then you can see that if we add up the increasing insurance and the decreasing insurance, we have a level death benefit. And here, the level death benefit amount is 5. And this is an N-year term insurance. Generalized to the N-year insurance. At the bottom, we have N-year increasing insurance, and then the top part, we have N-year decreasing insurance. Adding this up, we get a level death benefit of N plus 1. Therefore, we have the relationship. The N-year term increasing insurance plus the N-year term decreasing insurance, this equals to N plus 1 times the N-year term insurance. Let's establish a recursive formula for increasing and decreasing insurance respectively. For N-year term increasing insurance, we have this death benefit pattern. Consider the bottom part. Take the death benefit of $1 for an N-year term insurance. And then the top part, this corresponds to the N-1 year term increasing insurance issued on age X plus 1. Discount back to age X. And then we get the relationship. For increasing insurance, this relationship also applies to whole life insurance. For decreasing insurance, the N-year term insurance, and then the top part, this is the N-1 year decreasing insurance issued on age X. And we get the relationship. Let's take a look at an example. You are given some values, the values for N, and then the N-year term insurance issued on age 40, and then the corresponding N-year term increasing insurance. And we want to calculate the 5-year term decreasing insurance at age 40. All right, we are given IA, and we need to get a DA, and we are also given the N-year term insurance. So we can make use of this relationship. Here N equals 5. We get a 5-year term increasing insurance 0.385. And then on the right-hand side, we have 6, and then times the 5-year term insurance. Solving for that, we get the desired quantities. Let's take a look at another example. An insurance issue on 41 pays a death benefit of 1,000 times K plus 1, payable at the end of the year of death if death occurs between ages 41 plus K and 41 plus K plus 1. And this is a whole life increasing insurance. And given these 4 quantities, calculate the single net premium of this insurance. We need to get this expression 1,000 times IA41. That is, we need to get the quantity of IA41. And we are given IA40, and then a 1-year term insurance on 40, and then A41. That is, we'll use the recursive formula. All right, from this expression, we need to get A40 and P40. Let's get P40 first. We are given that a 1-year term insurance on 40 is 0.0056. This 1-year term insurance, the present value for this is simply nu times Q40. We get nu 1 over 1 plus I is 0.06. We can solve for Q40, and from that, we can get P40. Next, we need to get A40. We are given A41. We can use this recursive relationship. Nu times Q40, this is the 1-year term insurance, 0.0056. And then we get P40, and then A41 is given. Upon calculation, we get A40 equals 0.2391. Plug the numbers into the recursive formulas for the increasing insurance to get IA41. IA40 is given 4.9968, and then A40 is just calculated. And then we get nu, and then P40. Solving for IA41, which is 5.073265, and we need 1,000 times IA41, and then we get the answer. That's it for today's video. Thank you for watching, and see you in the next video.